Hello everyone, welcome back. Let's have a discussion over this question. Now, this question belongs to chemical kinetics, right? We are given a reaction where A is the reactant and B and C are the products formed. The reaction is of first order. As you can see in the question, at T is equal to 0, number of moles of reagent are N1. At T is equal to infinity, the number of moles of reagent is N2. Now, what is happening in this question is that the reaction is progressed, and in this reaction, there is a reagent R used, and we are doing the titration of reactant A or the products B and C with the reagent R, right? That means what is happening, let's say we have this container in which we have the reactant A. This A is getting converted into B and C, and we are doing the titration by using the reagent R, right? So if A, B and C, they react with the reagent and have n factors in the ratio of 1 is to 2 is to 3 with the reagent, then we need to find the value of K in the terms of T, N1 and N2, right? Now, how to approach this problem? See, at time t is equal to 0, we know only A is present. So that means at t is equal to 0, the reagent R will react with only A, right? Also, we know when the reagent reacts with the reactant, what do we equate? We equate the gram equivalents, correct? We will equate the gram equivalents of reactant and products. So if you look at this reaction, what we have done, we have just normally written the products and the reactants amount. At t is equal to 0, let's say we have n number of moles of A and 0 moles of B and C. At any time t, let's say x amount of A is getting consumed, or we can say if x amount of A is getting consumed, how much B should be formed. Now the mistake which is made here is that, as we know, generally what we do, what we write n minus x, and since the stoichiometric coefficient is 1, 1 and 1, we write n minus x, and for B it is x, and for C it is x. But here it is not like this, because we are given the n factors of each reactant and product, right? Now basically whenever a chemical reaction takes place, what do we write? We write number of gram equivalents of reactants is equal to number of gram equivalents of products, right? So if x is the amount of A getting consumed with the n factor of 1, so it will be x, and equivalently, if we have to calculate the number of gram equivalents of product, that is B, it will be number of moles of B formed into its n factor. So it will be 2x, right? So this is how we write it. Similarly for C, it is 3x. At time t is equal to infinity, what will happen? All of A will be consumed. So it will be 0. That means it will be 2n and 3n, right? Now at t is equal to infinity, A is totally finished, as I told you, and B and C is present. And the reagent R, it will react with only B and C, right? And at t is equal to infinity, how many moles of reagent are used? N2. If you look at the question, N2 moles of reagent are used at t is equal to infinity. That means N2 is equal to 5n. From where this 5n came? This is equal to the sum of number of moles of B and C. So if n2 is equal to 5n, from here we can easily calculate n. N is equal to n2 by 5. This is our first equation. Now second equation, at any time t, what is happening? The total number of moles of R and P, that is reactant and product available, how many are there? At any time t, we have n minus x plus 2x plus 3x. This is the total number of moles of reactants or products available at any time t, right? And for these number of moles, how many moles of reagents are required? It is n1, right? As you can see in the question, at any time t, n1 is the number of moles of reagents required. So we equate with the n1. From here, we can easily find x. So it will be n plus 4x is equal to n1, right? So from here, x will be equal to n1 minus n upon 4. This is how we can easily find the x, right? Now we need to find, see, the question is asking What do we need to do? We need to find the value of k. K is the rate constant for this one. So basically, because this reaction is following first order kinetics, so kt is equal to ln of n upon n minus x, right? At t is equal to 0, we had n number of moles of A. At any time t, we have n minus x number of moles of A. So directly putting the value of n and x in this equation, because we need the answer in the terms of t, n1 and n2. So let's say kt is equal to ln of n is there in the terms of n2, so n2 by 5 upon n minus x. Okay, let's do one thing. We can easily substitute the value of n as, let's say we find n minus x here. N is n2 by 5 minus x. X is n1 minus n by 4. Now again we have to put the value of n here also. So it is, let's say it is n2 by 5 minus n1 by 4 plus n by 4, right? And what is n? N is n2 by 5. So it will be n2 by 5 minus n1 by 4 plus n2 by 20, right? Now simply solving it, what do we do? Let's say I multiply up and below by 4. 4 is multiplied here, so it will be 20. So it will be 5 n2 by 20 minus n1 by 4, right? Now simply solving it further, it will be equal to how much? N2 by 4 minus n1 by 4. So n minus x is actually n2 minus n1 by 4. So n2 minus n1 upon 4. So ultimately the answer comes out to be ln of n2 upon n2 minus n1. 4 goes up and 5 comes down. This is the final answer. This is how we get the rate equation of first order in the terms of n2, n1 and k, right? Let's match the options. So the correct option will be option fourth, D option. I hope you understood the concept and I hope you understood how to solve this problem. For such more problems, stay tuned. Thank you.